Well, I must say I'm slightly overwhelmed. Thank you very much, Professor Birati. My entire life in about 12 minutes. I feel there's almost nothing left for me to say. But Dean and my fellow professors, I must just first say how honored I am to have this fellowship. I feel, although Professor Tercini says there are lots of courses in Italy doing architecture and engineering together, my feeling somehow is that Milan has been the birthplace of this idea, and it still really does hold the force of the idea. Milan somehow is looked upon as the design capital of Europe, and this idea of bringing architecture and engineering together and seeing them as a whole and reviewing them as a whole, I think started here, and I very much hope will remain here as the founding place. And so it's a huge pleasure for me to come to Milan to receive this honor. It's also a huge pleasure to have as my fellow Professor Del Mezzi, to be here from Arabs, because I've worked with Arabs all my life. From the very first project I did when I left college was with Arabs, with John Martin, who Professor Del Mezzi will know well. And I've admired Arabs as engineers all my life, and I knew Ove Arab himself when he was still alive. They, in my mind, are a model for all firms to look up to in the way they run themselves, the way they have an ethical belief in what they do, and a total belief that that technology and research can eventually resolve every problem. And we've come to them with some pretty difficult problems over the last 40 years. And they are prepared to spend the time to do it. And profit has never been a big motive in Arabs. And I know they've probably lost more money on my projects than practically any other ones they've done. But it's this determination to get things right which I admire, and this determination to do the research to get to get to the answer, which I think they're universally admired for throughout the world. And it's no accident, of course, that they've grown in such a way that they have. But they still have the democratic structure that they started off with, and still will spend the time with us to do the work. So it's wonderful to be here together. On this question of architecture and engineering, I think the first thing I'd like to say is that it has to start from the beginning. The architect cannot do a sketch and then develop an idea and then go and see the engineer and say, will it work? They have to be there together on the very first day to discuss things between themselves and throw the ideas to and fro. And that's what we've always done with our engineers. Of course, we haven't used Arabs for all our projects, quite often a client has some special relationship with an engineer and especially wants to use him, and normally we get on quite well with them, not always. But it is a question of being there right from the beginning and working side by side. And I think it's a rather happy accident that Professor Delmese ended up with a hexagonal structure. It's a complete accident on his presentation, and I start with one. And I also, for those who were at my lecture last night, will remember I also had the honeycomb just before this slide. So we have some natural issues which and some issues to do with the love of nature, I think, which also tie us together. Now, as I said, I did a lecture last night at the Triennale and went into quite a lot of detail on my projects. So now, really, I have just more like a kind of summary of the most recent projects and competitions, and I just make one or two comments about each of them as I go through. So I'm not going to give the sort of background detail to all these projects, particularly the development of the Eden project. Perhaps one thing I might say, because this is such a huge development, one of the things I always found fascinating about the work we did here and the development of the structure was that the structure itself weighs less than the air it encloses. And that's always been an important factor to me in terms of perhaps looking back to Buckminster Fuller, who was one of his favorite comments was always, "How much does your building weigh?" And that I think we would come out pretty well on. Now, is that going to change it? Okay. Well, you saw some other slides of Waterloo Eurostar terminal, which was a huge project for us in its time. We were quite a small firm when we got this project to do, and it was kind of billed as really the most exciting project you could possibly get at that time, about 1988. It was the terminus for the trains coming through the Channel Tunnel. It was the first time that the British Isles were being linked to the rest of Europe, and a lot of excitement surrounded this particular project. And we put a huge amount into this. One particular thing, that's the internal concourse, and one particular thing that I might mention about this one was that to do it, because of the complex geometry and the curves of the building, we had to get very heavily into computerized work. And in fact, that meant we threw all our drawing boards away in 1988. So we've not had a drawing board in the office since then. It's something I'm quite sad about, but it does not stop us all using our black Dalla sketchbooks, and they're issued free within the office for people to work on their concepts. Now, this moving very quickly through the projects, this is a recent one for the exhibition hall in Frankfurt, And this very much came to me when I was in the country, experimenting, looking at leaves lying on the ground and the way that the structure of them worked, and the way you could hold a leaf from one end and let it let it fan out, and the strength of it. And by my other slides, not these ones, do show how the rooftop was formed by interlocking leaves. This was an idea developed with Phil Dilley at Arabs, who's now the chairman, just showing how time passes. Then he was a young project engineer, and we worked very closely together on this project. And that's it from the outside. For a time, this building was the widest span building in Europe. And of course, the significant thing about it is that you in an exhibition hall, the only place really where the architect can show his sort of abilities is in the roof, because what's going on inside usually occupies 98% of everybody's time. But if they should happen to look up, hopefully they see something beautiful. Now this goes on to Ludwig Erhard House in Berlin. There was a slide of the outside earlier, and this is the lift shaft and the atrium. And actually, one interesting thing about technology is the lift cars were made by a panel beater who makes cars for bodies for antique rebuilding of antique motor cars, and he made all those lift shafts for us and was very glad of the work, I think. That's the interior, and you'll see coming down on the right-hand side of the picture these huge feet, which I was always keen represented. The whole building is an arch, and you have to see an arch come down to the ground, and all the office floors and all the floors of the building are hung from the arch. So in theory, we are leaving the ground completely free for future uses. And in fact, there was considerable speculation that the stock exchange, which was in the ground floor, would move or get taken out or get smaller or whatever. And the idea was that we would then have a completely free ground floor. It's nearly always the problem in cities that you can't use ground floors of buildings for everything you want to, because the columns come through from above. Here there are no columns, ground level. So for instance, you could have a huge ice rink or cinema or whatever in here over the period of years that the building is there. So it's a sort of a very high level of urban flexibility. And I think that's a particularly important issue when building a very large piece of a city, is to make it so that it can be changed and used for different things over a long period of time. Here, just as a grandstand, we did London's cricket ground. I suppose the interesting thing to say about this is that we demolished an existing stand, and that stand it was an absolute classic of bad design, in the sense that 60% of the seats had restricted view. So when somebody hit the ball in cricket, it disappeared out of your vision and then came back in again, if you were lucky. It's a few seconds later. And the criteria was that we were to have no columns at all. And I said, well, you can't actually have a stand with no columns. But we have one column in the middle towards the back, as you see, and then the rest of the stand hangs from that structure. And very good views had by everybody. Here was our biggest, our tallest tower building, which we obtained planning permission for in London. And it consisted of two kind of triangles with an atrium between them up to a certain point. And this was a fantastic experience in fighting something through a planning battle, really. And again, worked on with Arabs over a number of years. Very ecological building with a reactive skin, and we were trying to work on the idea that for the majority of the year and the most of the time you didn't use air conditioning for this building by a very complex double skin development. And at the same time we had developed another building for this same site, which was half the size. And in the end, in economic terms, the client decided that they'd make more money by building a building half the size, which was rather, in a way, a sad outcome for us. But actually, the building is going up. And again, Arabs are the engineers. Now I come to think of it. And in fact, this building was Tony Fitzpatrick originally, who very, very sadly died a few years ago. And there's a view from the across the Thames, and you can see the Foster's Gherkin building on the left. We were quite pleased with ourselves at the time that we'd got something going up considerably higher, but it wasn't to be. And then we turned to the building in Melbourne, Australia, Southern Cross. Railway station, a lot of work. I haven't got the diagrams, but you can see from these kind of humps like snow drifts or sand dunes. They create zones in the roof space to collect the hot air, which is then extracted at the top. And there's quite a complex calculation showing the way the skin heats up and draws the hot air to the top of the building and extracts it. And the winds come from every different direction, so we couldn't make a ridge going across the building. We had to make these humps. Needless to say that Australians can think of lots of rude words for them, but sand dunes, I think, is probably the best one we've got. And there it is from the roof. And the interesting thing to say about this one is that when you come down now onto the platforms from an overhead walkway, and we've used all the we've got something around about 40,000 square meters of roof here. We collect all the rainwater, and we've used what used to be the pedestrian underpasses as water storage. So to collect the rainwater and for use in watering the parks in Melbourne, because they're very, very short of water. This is a more recent art building in Coruña in Spain, on the waterfront. And perhaps an interesting, I haven't got many slides of that, an interesting aspect of this is that the way sometimes you, as an architect, you have to deal with things. We already started building the building, and the client announced they wanted to have a lecture theatre underneath it. And we said, but it's solid rock. And they said, well, we don't mind how much it costs. Of course, they didn't mean that. They meant they didn't mind how much it cost within reason. And we had to dig down. It took 2 years extra time. We dug down into solid rock. We had to, below sea level, we had to put anchor piles in, going down, I think, 150 meters to hold the building down, to stop the sea, the water level, pushing it out of the ground. But they got, I think, what is quite a beautiful lecture theatre, and I somehow couldn't help admiring them, because the idea of building, they wanted to have poetry there. So if they want to have poetry, why not? And they do concerts and poetry readings. And somehow I thought it was a wonderful cultural aspiration. Oh, now here we go back to where that tall building was, and look at the small building which took its place, which is now half up. And you can't really clearly see from that diagram, but the interesting thing about that building, wait a minute. The interesting thing about that building, if you can see the bank of lifts, each one of those lifts has, those lift shafts has 2 lifts in it, and they can go up and down independently of each other. It's a concept which absolutely terrifies me, but is looked upon as being a perfectly safe and normal thing to do. I keep saying, do they have springs on the roof of the lift underneath, in case the top one comes down on top of it? But apparently the technology is so good now, it's 100% safe, and there are several, Thyssens have done several installations in Germany. So we'll be watching that with great interest. This is Zurich Airport, that some people will know. Not being far from here, we redid the entire front of the airport, and again, a complex skin on the front of that building, because we felt it was very important to see out over the airport and see the aircraft, but of course it was in fact southwest facing, so the heat gain problems were terrific. And so we had to have a very complex array of louvers on the outside to stop too much heat gain coming into the outside. We tried to control the shopping, which is always the worst thing that happens in airports. We moved to the Rolls-Royce factory in an area of outstanding natural beauty in England. It's 50,000 square meters of grass roof, and very effectively deals with the collection of rainwater. It has wooden louvers on the outside, and it's generally liked because it fits in with the countryside pretty well. As to the greenness of Rolls-Royce cars, there's quite a nice story. They've just had their centenary. They've been producing cars for 100 years, and they have 97% of them still on the road. And that you might think is quite a green statistic, because of course the old ones are classics now, probably kept in garages and taken out once a week, but they're all still on the road. And if we took that approach with all the cars we drive now, where the parts can be replaced and the car can be renewed, we'd be a lot better off, although the car manufacturers wouldn't be so well off. This was the scheme for St. Petersburg Airport at Pulkovo. It's based on an idea whereby the roof holds the snow load, and the snow is used for insulation, and the drainage down from the roof comes internally as the snow thaws out in the springtime. The snow rests there the whole winter, and so we're using the snow, and we're also stopping it sliding off the roof and keeping it sort of under control. I was told very forcefully by people who live in St. Petersburg they don't really like snow, and where they're not, they don't feel romantic about it like we do in England. This is Bijlmer Station in Amsterdam, high-speed train. This is an area which can be pretty rough. It's the entry to the main football stadium at Bijlmer, the Ajax Stadium in Amsterdam. And part of our brief was to try to humanize it and make it feel that people didn't want to vandalize it. And in fact, so far, it's been quite successful in that respect. People seem to quite like it as a structure, and the access underneath it is all quite nicely finished. A few brief slides of the Eden project, just showing it all completely finished with all the landscaping around it, blending into it, which I think was a very important aspect. And the new building at the bottom is the new building we're very proud of, because we got virtually 100% on green building rules for it. It's based on the phyllotaxis, the kind of growth pattern of a plant, and it's built entirely with green materials, mostly timber. That's the inside of Eden after the first planting of it. Much taller plants now. A bridge in Wales, a small speculative scheme in Duisburg in Germany, called the Five Boats, and an interesting, perhaps one in Mexico, the Mexican National Steel Museum, which we based on a blast furnace which had was stopped just when the steel industry ended. It just stopped in the middle of the day, one day, and that was it. And we were given the blast furnace and said, build a museum based on that. And most of the material we used was steel, in fact. There's steel louvers to stop the sun hitting the building, steel staircase inside, quite elegantly done. Oh, and that's all we've got on that one. This is Fulton Street in New York, near 1 block from Ground Zero, a huge concourse where 7 subway lines cross over, and we make the connections between them. And there it is from the outside. And then I think finally you might recognize this street map. This is our station, this is our scheme at the Garibaldi area, and I'm not entirely sure what images I've got of this, but look, we'll soon see. And so here's the site plan, and you can see this quite peculiar shaped building, which comes to one end of the whole scheme where the tower blocks are going up next to that piazza. And the idea here was to have a absolutely standard piece of exhibition space. It's 2 levels, completely rectilinear. I don't think there's a section in the other direction, but these 2 halls are immense and completely rectilinear, and then around it we wrap this this kind of snake-like skin. Oh, here we are. Here's the plan view, so you can see the scale of that exhibition hall. And if you talk to any exhibition promoter, they only want completely rectilinear black box kind of space, which doesn't make a terribly exciting building. And so the idea was to give this some kind of a face to the outside, to the people of Milan who weren't actually using it. So you get this concourse, and all the lifts are outside the black box area, and then we wrap the whole thing with a kind of skin which is which is made up out of folded plywood ribs which wrap over the building and open up in various places to let in daylight. And you can see here how we open them up and let glazing come in. And this is how the skin developed to wrap over it. And here is the twisted shape that those plywood beams take up in order to give themselves structural strength. So it is a wrapping, but it's meant to be a wrapping. And then in the end of the building, we had this idea of having a vast digital screen which showed what was happening inside the building, what kind of exhibition was taking place. And so the idea of this was to have at least one remaining exhibition building right in the center of Milan, even though the whole exhibition park is moving to the outside. And this will be going up as part of the project which is already underway, which you're all aware of. And here's an interior view of that. And there's the exterior skin. It's a big project, this. You can see from the scale of the people. And that gives you clearly the idea of how the skin opens up. And there's also a roof terrace, which I know is a very popular concept in Milan. And it doesn't look as though you can see out over the city from what's shown there, but if I can click back to the section, you can see on the left the roof terrace. I think you will get pretty good views out over Milan from the top there, and of course restaurants and so on internally for bad weather. Well, I think that's the end of what I have to say. I can only I normally like speaking with lots of details on the screen, but I hadn't planned to do that today because of my lecture last night. But I hope that's given you some idea of the sort of projects we do and how wedded we are to this concept of architecture and engineering, and of the fact that details matter so much. And as I finished my lecture last night, I'll finish today and say, I think the forces on us now to be sustainable and to be responsible with our use of energy should, and I say should, be influencing architecture much more than they are so far. But I hope to see those forces of sustainability and energy saving, shaping our buildings in the future, So you can look at the buildings and you can see why they look the way they do, because they've designed to use the right materials and build responsibly. So in a sense, we perhaps could be entering an age where buildings are again celebrated for their function and efficiency and brilliant use of materials than for simply style. Thank you very much.